Hello students, welcome to the online class of Physics, Mechanics Unit 4, Paper 1. I'm N. Chandana, Assistant Professor of Physics from Government Degree College, Kharkabad, Hyderabad. Let us have a quick recap on the previous class, what we have taught. We have done Galilean transformations. So in Galilean transformations, we have obtained the relations between the velocity from one frame of reference to the other frame of reference. Like this is k and this is k dash. Now we obtained the relation between the velocity of an object which is present somewhere here. Then what is if the velocity is u dash in the second frame? Then in terms of this we have written as second right here. Or else if x dash is the position second frame, x minus vt. V is the velocity with which the second frame is moving with respect to the first frame. Okay, so x dash equal to x minus vt. Similarly, y dash equal to y minus vt. Okay, and when we just consider a case which is parallel, exactly parallel to our x direction, then y dash will be y and z dash will be z and t dash will be t. Okay, now we also have Galilean invariance, right? What is Galilean invariance? See here, let me explain you a few points regarding Galilean invariance. Either hypothesis and Michaelson-Morley experiment. Let us have a few. I've just explained you the experimental arrangement. Let us see the concept, entire concept here. Either hypothesis also I give a quick introduction and we'll go in depth. Okay, let me tell what is Galilean invariance. Today, let us go to the concepts now. Let me share whiteboard. Okay, see here, what is Galilean invariance? So what do they say is, according to Galileo, in any inertial frame of reference, the quantities never change. Okay, that means in any inertial frame of reference, all the basic laws of physics are identical. Okay, like the basic laws of physics are identical. Okay, in all inertial frames of reference. All inertial frames of reference. Okay. The basic laws of physics are identical in all inertial frames of reference. So this is Galilean invariance. Now let us see one of the law. Okay. You very know that invariance of Newton's law. Let us see. See, you know, Newton's second law is equal to ma equal to m into d square x by dt square, right? M into d square x by dt square. So we know that according to Galilean transformations, now we have x dash equal to x minus vt, okay, and y dash equal to y, and z dash equal to z, and t dash equal to t. You know this. These are called Galilean transformations, right? From one frame of reference to another frame of reference, what would be the transformation of coordinates or the position coordinates here? X dash, y dash, z dash, and t dash are from s dash, while x, y, z, and t are from which frame? S frame. Where s dash is moving with a velocity, this is s dash, is moving with a velocity v dash. Okay, v with velocity v in this direction, in x direction, parallel to x, right? Hence we have x dash equal to displacement is happening along the x direction. So we have x dash equal to x minus vt because the time with which it is traveling is t. So v into t, velocity into time gives you displacement, right? So displacement is given by vt. So x minus vt gives you x dash, y dash equal to y, z dash equal to z, and t dash equal to t. Okay, now now let us do one thing, like let us differentiate these equations. Okay, let me erase this. And now we have x dash equal to x minus vt, y dash equal to y, z dash equal to z, and t dash equal to t. Now let us differentiate on both sides. We get dx dash by dt equal to dx by dt minus v, right? So what would be happening now? D square x dash by dt square, differentiating on both sides. D square x by dt square. Okay, minus 0. Why 0? Because v is constant, right? The constant velocity with which s dash is traveling with respect to s frame is v. So d square x dash by dt square is equal to d square x by dt square. Okay. So now we can say that from Newtonian mechanics, F is equal to md square x by dt. So this is Newton's second law, as I have written before prior. So in system, this is from in system S. Now in system S dash, F dash equal to m dash d square x dash by dt square. Okay. So that is equal to m. M dash is m. Okay. According to classical mechanics, mass doesn't vary. So d square x by dt square. Since d square x dash by dt square equal to d square x by dt square. That means f dash equal to f. So the second law is unchanged. So the Newton's second law is unchanged. So it is remaining constant. Okay. In under what? Under Galilean transformations. The Galilean transformation. This is a basic example that we have taken. So Newton's second law is unchanged in under Galilean transformation. So this is called this unchanging principle. That means there is no change. That is, there is no variance. That means this is called Galilean invariance. This is called Galilean invariance. Okay. This phenomenon is called Galilean invariance. That means basic laws of physics are identical in all inertial frames of reference with respect to Galilean transformations. So such type of variance is called Galilean invariance. Okay. Now we can even go for a momentum. It is also not very. Now let us go for Michaelson-Morley experiment. Okay. What is Michaelson and Morley experiment? As I have discussed in the previous class that, see, uh, by accepting the wave theory of light, then what happened? These people, Michaelson and Morley, along with Lorentz, have thought that there is a medium surrounding the earth in the space called ether. They named it as ether medium. Okay. They considered that it should be it is invisible, it is perfectly elastic. Okay. It is transparent, it is non-resistive. Okay. It has low density. All these properties they have studied regarding ether medium. Like they have assumed that ether is of having all these properties. Okay. Now they considered that if this ether medium is constant, if I consider a frame here, frame of reference in this ether medium, then from this ether medium, we have to calculate, we can easily calculate the velocity of Earth. And the accurate velocity of Earth can be, the absolute velocity of Earth can be determined from this ether medium's frame of reference. They have considered this assumption. Okay, so hence the Miss Michaelson and Morley have done one experiment. See, I have told you yesterday in the previous class that Michaelson has won Nobel Prize 1907. He's the first American scientist to get Nobel Prize. So they want to measure accurate value of Earth velocity. Okay, from the ether medium. Okay, now what is the experimental arrangement? Okay, the experimental arrangement. So you first we have to write what is our aim of this experiment. Michaelson and Morley experiment. If they give you for your exam, this is an interferometer. Based on interference, this experiment is. So you have to write down what is the aim of this experiment, for what purpose, to determine the velocity of Earth, so that we can understand, study different uh, physical properties of various objects from this frame of reference. Okay, so that's the reason this Michaelson and Morley has carried out this experiment. So now, what is the aim of this experiment? We have described. Now, next one, what we have to do is experimental arrangement. Okay. I take a monochromatic source of light. This is Michaelson interferometer. This is source. This is lens. This is a convex lens. So that what does it make? It collimates it makes the beam parallel. Okay. This is source. Monochromatic light source. Lens, convex lens cell, which makes the beam parallel. Then when it is made to fall on semi-silvered glass plate or partially silvered glass plate, this is G. Okay, now what happens? It gets reflected, right? Because it is semi-silvered glass plate, one part of the beam gets reflected, the other part gets transmitted or refracted, and here we have a mirror. Okay, mirror at position A. This mirror is M1, and now there is a mirror here. One second. Okay, now my mirror is here, M2, where this point is B, if I suppose, right? Now I have B dash, this is M2 dash. I'll tell you what is this. This is M1 dash. Sorry, with this pen I'm unable to draw nicely. M1 dash. Now this is G dash. Now my refracted or refraction happens here from one medium to another medium, then it gets translated in the air medium. So it traveled to some distance and it has hit here at B. Okay, the other one got mirror, and again it gets reflected back, right? Because it's a mirror. It's a mirror. M1 and M2 are the mirrors. Okay, then what happens? Then again this beam comes back, and then it gets interfered here. The interference pattern will be observed here in the telescope. Okay, now let me take this as point D. This point is A dash, similar to that of here B dash. Okay, this is B, this is A, this is A, and this is A dash. Okay, now what's happening is here, this is moving with velocity B. Okay, because now let me tell you one more thing. Now what is happening? Light coming from a monochromatic source S is collimated or made rendered parallel by using lens, convex lens L. Okay. Now this parallel beam of light, this light coming out of this lens is made to fall uh, on a semi-silvered glass plate G. Okay. Now what is happening here? The part of that incident light gets reflected here, and the part getting transmitted here. So now the reflected thing, what is happening? Uh, Again, it comes back purely reflected from this M1, and here it is from M2, and they get interfere, and we see the interference pattern. Okay. Okay. Now, if at all we think that the two either medium is at rest. Okay, like if the apparatus is at rest, the apparatus is at rest in either medium, then it will take equal time, right? From here to here, from here to here, equal time, because M1 and M2 are placed at equal distances from G. One is in this direction and one is, both are perpendicular to each other, but they are at equal distances from G. Now what happens? Now they'll come and interfere, and hence what happens? There will be return the glass plate G in equal time, and hence the interference pattern can be seen here. But you know that the entire apparatus is moving along with Earth, moving along with Earth, right? So let us suppose that this entire apparatus is moving in the direction of the Earth, like it spins, right? So now if the Earth is spinning in this way, now this apparatus is also moving in this way, along with the Earth, in the direction of the Earth. Then what happens? Then the path difference will be changing, right? See, now after some time what happens? Once this light ray goes there, then immediately what happens? This entire equipment will get shifted because it is moving with velocity v bar, right? So the ray no more hits here, but it hits here. Light ray, reflected ray will hit here. Okay, and then again it gets here. You understand? It no more hits the mirror here, but it's hits in this way, because mirror M1 is not at A now, it is at A dash after some time t, and this is moving with velocity in the direction of the Earth. Similarly, it is no more M2 is at B, it is at B dash. So now what will be the path difference now between these two rays? Because we have to calculate the path difference, right? Because path difference is n lambda, that gives you maximum. And path difference is 2n plus 1 into lambda by 2. It is minima, dark. And this is bright or maximum. Right? Now, the reflections now will not take place at A, but at A dash and B dash. Okay. Now let us see, let us calculate the distance. Let us take some values and let us obtain the expression of velocity by obtaining the path difference. Okay. Now let me explain you. This is, if this is L, if I consider that this is L, distance bit from here to here, this will be L and L. Okay. Now what would be this? This is the distance from A to A dash, right? A to A dash. And now let me calculate the total path of the ray, first ray, from G to A dash, from A dash to G dash, G to A dash, and from, so G A dash, G dash. Okay, G A dash, G dash, right? By ray 1. What about ray 2? Ray 2 is in this way, right? Like G, B, G, B, B dash, and again it's coming back, right? 2 times it's coming, right? So what I'll write now, like let me write first these equations. Clear the diagram. I'll draw it simple here in the corner. This is M1 at point A mirror. I have This is M2. Okay. Now at B M1 dash at B1, sorry, A dash. See here, this is my mirror G dash. How it's getting here, that is, this is a perpendicular drawn on this. This is ray 1, right? So now let us see only ray 1. It's traveling from G to A dash and then from A dash to G dash. This is the total path traveled by what? Ray 1. Ray 1 because of this is moving with velocity V bar. Okay, now the total path of the ray from G to A dash and back will be G A dash G, right? So we can write G A dash whole square from this triangle. G A dash whole square is equal to hypotenuse square is equal to GD whole square plus A dash D whole square. GD whole square plus A dash D whole square. What is GD? A dash, right? A dash whole square plus A dash D whole square. Okay. Now what is GA dash? Because it is moving with a velocity V in time t, that is distance is equal to V into t, right? GA dash equal to VT whole square, right? VT whole square, or because it's moving, the light ray is traveling with the velocity C, CT whole square. I'm talking about light ray, right? Not the equipment. CT whole square is equal to, what is A dash whole square? This is VT whole square plus L square. A dash D, this is L. This is L. Okay. A dash D whole square. So what happens now? T square into C square minus V square equal to L square implies T square equal to L square by C square minus V square. Okay. Implies T is equal to L by root C square minus V square. Okay. Now what is happening now? It's going and again it is traveling this much distance, it's coming back. Right? Entire whole path G A dash and G. G A dash G dash. It will be given by 2T equal to T1. T1 for ray 1, total time taken. So T1 is equal to 2L by root C square minus V square. Okay. So 2L into 1 minus V square by C square whole power minus half. Right. I have taken C square common. Okay. So 2L by C. Because C square I have taken common and it comes as C. Then what happens? This is binomial expansion, right? 1 plus nx whole power x, 1 plus x whole power n, right? Whole power n equal to 1 plus nx plus n into n minus 1 by 1 into 2 into x square plus and so on. You can put x in the place of x anything and in place of n any number. Okay, and you'll get the same expression. So I'll take first one, 2L by C into 1 minus V square by C square whole power minus half. So plus half. So 1 plus V square by 2C square. Okay, when we go into extreme, because C is very large, so in denominator, if it is increasing C power 4, then what happens? Then we can neglect the term because it is having low value. 2L by C into 1 plus V square by C square. This is the time travel, total time traveled for the light ray 1 from G to G dash through A dash. Okay, so the total time is T1 is equal to 2L by C into 1 plus V square by 2C square. Similarly, for ray 2, if I consider for ray 2, see it is traveling this way and it is coming back again this way, the same path, right? So first path is this way. The velocity with which it is moving is V bar. The velocity of light is C bar. So what is the relative velocity? L by C minus V. C minus V, right? When coming back, moving forward, it is C minus V because they are in same direction. While coming back, that is in opposite direction. So L by C plus V. So what I get from this equation, L into C plus V plus L into C minus V by C square minus V square, A plus B into A minus B. So 2LC by C square minus V square, because this one and this one will get cancelled out. Right? Can write it as 2L by C into 1 by 1 minus V square by C square. Finally, I'll get it as 1 minus V square by C square whole power minus 1. Then by binomial expansion, both gets cancelled out on 1 plus V square by C square. This is T2, time taken by wave 2. So total time traveled is delta T will be net T2 minus T1. Okay, difference on longitudinal transfers will be delta T, time difference. So 2L by C into 1 plus V square by C square minus 2L by C 1 plus V square by 2C square by 2C square. Okay, so what I'll get, 2L by C V square by 2C square, that is equal to 2 will get cancelled, LV square by C cube, right? LV square by C cube is the time difference. So what would be the path difference? Path difference equal to time difference into velocity, right? So velocity into time difference. Velocity of light is C. So C into LV square by C cube. Okay. So C gets cancelled. So LV square by C square. This is the path difference, optical path difference of the light traveled in this, right? But when we have lambda as the wavelength, then path difference will be LV square by lambda C square. Okay. Now Michaelson and Moley has conducted the experiment in where they have interchanged mirrors. So they put here M2 and here M1 perpendicular. They have interchanged M1 to M2 and M2 to M1, and they have conducted experiment again. They have obtained the same expression. LV square by lambda C square is the path difference. Okay. So now what would be the total? 2LV square by lambda C square. 2LV square by lambda C square. Okay. Now after calculating this, they got the calculation, they expected it to be 0.4 fringe. Okay. But experimentally they have obtained it to be only 0.01 fringe. Okay. In which the error is also included. So then it should be around 0.4, but it has come to 0.01. Hence, it is a negative result. So the experiment entire hypothesis, so we need 0.4, and we obtained on they have obtained in experiment. In theory, 0.4 fringe shifting they have to obtain, but they have obtained only in experiment 0.01. Okay, hence the entire either hypothesis got failed. This got failed. Okay, so hence we can say that the speed of light in vacuum is same in all frames of reference which are in uniform relative motion. Okay, so the speed of light is same. Okay, is same in different in all frames of reference which are in uniform relative motion. Uniform relative motion. Okay, this was given by this experiment. Okay, now later this negative result was explained by Lorentz result hypothesis and light velocity hypothesis and other things, because of why we didn't get this, because they thought that either is dragged by earth, like either is also spinned around the earth, either is a space, so either is also dragged around with the earth motion, the earth spin. Because of that, they have explained you the negative result by either drag theory. It explains the negative result. And also Lorentz contraction, Frizzle contraction hypothesis also explain you the negative result. Okay. And also light velocity hypothesis. Okay. Okay, we have three types of negative result explanation. So you could just go through that, you'll easily understand. Okay. In next class, I'll deal about Einstein's postulates of a special theory of relativity. Okay, students. So Lorentz-Frizzell hypothesis. Now, next class we'll go for Einstein's postulates. Okay, students. So thank you so much. Thank you so much for your